What is going on, guys? Welcome to the Wednesday live stream. Tonight we have a Trust. How you doing, buddy?
Doing just great. Thanks for having me.
Thanks for joining me. So it's been a while since we've chatted. We did a video probably a couple years back about algae, which was actually really awesome, at the Top Shelf Lab, and it looks like you've been expanding things. So it's really cool to see.
Yeah, it's been really cool. I've had a very, very good fortune of quite a few of my products were a success, very popular. So it got a little bit untenable, kind of crawling underneath the sumps of the different coral systems and having different systems set up there. And so unfortunately, there was a local pet store here in Orlando that went out of business, and then it was acquired by us. So I got to move in, renovate, and now it's now a full production aquaculture laboratory. So I'm very happy to announce we have the Calypso Aquaculture Laboratory. I'm the proud, director of it. Just me and my assistant, Mauricio Chang, who I've had the pleasure of working with over the last 6 months or so. We've had some fun, some successes. I mean, we're having a lot of good growing pains. We're growing very rapidly. I mean, a lot of our struggles are, just being like, okay, this worked, but we also want to do this. This is also working. We're at a period right now where if we encounter any major resistance, we kind of go towards focusing on things that are more our strengths. I want to talk a little bit about our facility, what we do here, what we want to do in the future.
That's awesome.
And then maybe kind of zoom out a little bit more towards the challenges of marine larviculture in general. Why are captive bred aquarium fish so gosh darn expensive? And kind of explore some just general realities about that are kind of bigger than any one particular company or industry. And then if we have some time, we'll maybe zoom out one little phase and see what all that excitement has to offer the industry at large. Because I think we really are in exciting times when it comes to the aquarium industry and aquaculture. And
that's
thanks
awesome
for having me.
No, appreciate it. Yeah, no, that's awesome. That's exciting. You got basically a full lab space now to go deeper and deeper into this, which is really exciting.
Yeah, I mean, the big issue, not an issue, but the big thing right now is that, okay, everything we do, we need to have follow through with. And that's, some of the other things I'd like to talk about today, kind of the transition between the hobbyist to being the actual commercial farmer. Because kind of weird, we're actually, especially me personally, kind of in a phase right now where not only am I not really afraid of competition, but I kind of want to encourage it to a degree. It kind of helps with this knowledge base that we have, considering just how many diverse organisms we're working with. And just having more and more people excited about breeding fish, invertebrates, seaweed, corals. It's just, we really do benefit from the successes of other people right now, far more than any one particular company suffers. So that's why I love doing these talks, kind of celebrating where we are at, where I experience challenges, and then everyone that might be excited about breeding even their first clownfish or bangai. I mean, kind of get excited about that process.
It is exciting when you get that, when you first get your clownfish eggs. I have one buddy that has some now. I'm like, all right, start getting Phyto, start getting rotifers going. I've had bangais in the male's mouth, but then I never actually saw the babies ever come out. So I don't know whatever happened, but it'd be fun to try that again at some point. So it definitely is exciting when that first time that happens. You're like, I'm a dad. Got your little fish babies out there. But it's fun.
It's my favorite part of this hobby, that it's fun. It's really frontier science, and we can talk about the chemistry, and you kind of need to. We'll talk about why you kind of can't escape it to a point. Anyone in the reef industry knows you can't really escape the chemistry. You don't have to dwell on it. But it's fun. You see those baby fish, and it's magic. And it's a lot of science that goes into doing that, no matter, what you're doing. So it's really cool. We're in an exciting time where there's a lot of technology and passions getting intertwined. That's why I love this industry. I love to be a part of it.
So I guess just as we're getting started, is there anything that you're excited to try and crack? Is there any inverts or fish or something that you're like, I'm going to figure out how to breed these?
So one baseline critter, there's two. We'll talk about something really basic. And then something more frontier. The first thing I'm very excited about is peppermint shrimp.
Nice.
It's one of those things where a lot of them are wild collected in Florida, but we do have seasonal droughts. And I've talked to collectors, and it is getting more and more and more difficult to harvest these critters for a profit. Some of the collectors I've talked to are even getting on stone crab boats and are having to modify, traps on top of stone crab gear. So you're really trying to, there's really more and more costs associated with collecting organisms. So we'll talk about sustainability, but everyone talks about, tree hugging, environmental sustainability, keeping the system going. That's valuable, but economic sustainability is a very true reality as well. I mean, everyone's all too well aware that gasoline is probably never going to get cheaper in the foreseeable, hopefully plateaus. But these are all costs that make wild critters, it's why fundamentally they will be more expensive
over time.
Than they ever were.
That scale's getting closer and closer.
Exactly. And having that so pepper and shrimp are one of those things where there's a market imperative. There's enough of a source of wild broodstock, which is always really important. We don't have the time or personnel right now to be dealing with precious things. And if you can do a peppermint shrimp, it's a nice combination of something that's been done many, 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 many times. I think I have a wonderful, I have a visual aid, how to breed your peppermint shrimp.
Nice.
It's a fun read. So it's been done in a laboratory setting and obviously in commercial aquaculture enough, but it's doable. And you can get enough production, and at Top Shelf we can sell them to ourselves, which is very, very nice. And it'd be very nice to be able to have that. But if you can go through that entire phase of going through a hatched peppermint shrimp all the way up to a juvenile, you've kind of gone through at least the outward outline of the full production scheme you need to have to raise a larvae and then basically be able to grow it in a way where you're actually making money at the end of the day. So that's a big part of this, the whole economic sustainability, to actually be able to make the larvae and then have the larvae exist as a consistently priced product that's not in the triple digits.
Yep, no, that's fair. So I know clownfish, for instance, is probably the easiest one to breed. Essentially, you need to be culturing rotifers for it. And then you got to be culturing Phyto to feed the rotifers. So as a base, if someone wants to get into it, like that's kind of, you got to be on your Phyto and then whatever your live feed is, at least for a lot of reef fish. Have you found anything that doesn't work with a live feed, or is like live feed or nothing more or less for a lot of the...
I'm glad you mentioned that, because there was something else that's on the list right now. We've had a lot of projects going, so this is on the back burner. But it is very much my intention to be working with the Bangai cardinals, which do not have a larval life stage. They actually come out fairly fully metamorphosed, which is really cool. I had the privilege of going to Long Island Aquarium and seeing Joe Aiullo's facility. And one of the coolest features of that is all the different Bangais they have in the lower parts of their coral reef. And then they have this very, very large mass volume discharge that goes through the tank, and they can actually collect all kinds of eggs that come from the Bangai and juvenile Bangais. And they were actually ranching them out and growing them in a little back lab in back of the aquarium there. Cool. So Bangais are nice because in theory, like, you don't really need to go through all these larval, certainly all the larval stages, but you don't need to go through all the nuanced live feeds as well. And yet they're still a great story, almost extinct in the wild, still very imperiled in the wild, yet there's something that took a lot of time and investment on the behalf of a lot of foundations, the Indonesian people, to domesticate or rather captively breed. And it's something that would be all too important to have substantial stocks of here in the United States, because, there's probably going to be a reality here where adult fish that are capable of breeding long-term, the genetic diversity of having enough of those fish so you can have a sustainable colony is going to become something worth prizing, just like we prize horses and dogs and certain plant cultivars now. But Bangais are a great example, in my opinion, because they're very achievable without having to do the rotifers and the artemia for the clownfish, which at the end of the day is still a huge, overhaul to entry. I mean, especially when comparing it to, the wide range of freshwater fish you can breed with seemingly 2 10-gallons and just crushed up microfoods.
I remember back in the day I was breeding what are they called, celestial pearl daniels, and like I just make these little like moppy things and they go inside it, and it was actually pretty darn easy in the grand scheme of things looking back at it. But
it's great, and it's why the freshwater aquarium industry experienced all the same challenges we did, and it's why one of their natural answers were, for many species, especially in the state of Florida here, we're going to cut out reliance on wild stocks in Central and South America. when possible, we will try and domesticate these fish, lower the price, increase the control we have, so they're not real parasites, the seasonal availability. We cut out middlemen. And the big obstacle for getting marine fish to follow suit was basically a lack of knowledge, which has basically been shattered since, I hate to say it, Finding Nemo and the economic imperative to produce these species that expanded so much of the hobby demand.
Now, so you're starting with peppermint, which is one good one. Is there any special tricks? Like, is there anything really what do the larval eat? Like, what do you have to do to raise them? Like, because I know I've had them with eggs, and I don't, they obviously never came to it, but like, what does it take to actually get the larval to,
So basically, when it comes to breeding any larval species, we need to know how big they hatch at. That's a big crucial question. Now, thank goodness with at least all the species I'm familiar with, all the Lysimatas, they come out pretty darn big. I haven't really settled any here. We get very much, but the ones I've hatched, I mean, they're able to eat brine shrimp, if not adult copepods, out of the egg.
Nice.
You don't need to, it seems, have any nauplii, any very small, it's not like a tang larvae, for instance, where it's a very, very small mouth. And they seem to come out fairly fully developed. They have eyes, they have appendages, they have guts. I assume they have a functioning gut microbiome. And it kind of makes sense. I can't really take the screen with me, but if we took some of my brood stock that I have now, I have some shrimp with me, they're always buried. They have eggs. And what that means is that the mom is carrying the eggs around and she's fanning them with those little tail appendages, and she's aerating them. So there's a lot of maternal investment and also relatively small amounts of eggs, like a few, like 100 tops, I forget, count them individually. But it's not like, let's say, a big pelagic tuna would probably lay almost billions of eggs at a time, millions of eggs, millions surely at a time, and then tiny, tiny specks. And the larvae that come out, they don't have eyes and they don't have barely formed mouth. So long story short, how it hatches is the big quintessential question of what makes stuff really, really difficult, if not impossible, versus it's already been done, or there's no reason why it couldn't be done. Yeah. So peppermint shrimp show up pretty far on the right side of the spectrum. They show up, they can, in fact, it's kind of interesting in that book, as long as you have the filtration down, she recommends that you can even maybe feed inert diets from the start. So you can just crush up flake foods, and as long as you can keep them clean. Now that's the next key question, because a lot of this is you're going to have a separate rearing vessel for your larvae. That's the big reason why a lot of this stuff doesn't recruit in our aquariums in the first place. Surely some bang guys might pop up in Joyulo's system, but his tangs are not going to breed, most likely. They're not going to go through a very long 30-plus day larval life cycle going through the pumps.
Yeah, nothing else. The skimmer and the socks and everything else.
Yes, it's not that. So you need to make a system that caters to that, which is cool because we have things like oyster hatcheries and obviously places like Pro Aquatics that are already starting to experiment. Certainly a lot of public aquariums that have received grant funding. Shrimp hatcheries are another. So we kind of have this spectrum of established industries that have worked with these larvae, and they have different techniques and different means of essentially having ways of preserving the water quality while you have some sort of cradle. It's going to be some place where the larvae stay, and it's going to be soft, and you can feed them. You're going to have to keep them oftentimes continuously in suspension without having tearing them up. There's a trick to that. And then you're always going to have at the same time be constantly feeding them because they are babies and they're constantly growing and starve within half a day. And you need to keep the water quality, in some cases, almost pristine.
Yep.
Already there is an extreme balancing act where, depending on which critter you're dealing with and how your water comes in, what you're feeding and how, now you're kind of entering the great, welcome. You've entered into the twilight zone. Like that's where, we are now enjoying more and more successes, but where there is not necessarily one set of optimized protocols. So yeah, it's so at this point, you're definitely going to need to know if your critter is doable. Like if you're trying to breed, if you're trying to do cleaner wrasses, that's going to be a much harder experiment to try than your bang or even your clownfish, for instance.
Yep.
And then you're going to need to have your rearing vessel. then you're gonna have to find a way to, depending on if like you're actually collecting eggs or juvenile fry, whatever you happen to find, or what your strategy is, you're gonna have to find a way to even nurse the eggs in its own vessel, and then find a way to incorporate them into your larval rearing vessel.
Yep.
So at that point, you need to give up your life. So that's why a lot of this stuff we haven't done yet, because you know, we're looking into potentially having Mauricio be here 7 days a week with reduced shifts, because he already works at a restaurant on the weekends, and I'd like to just make money with him instead. But you need someone that can feed these babies 24 hours. And if you don't have enough staff to do rolling shifts, you need to basically dedicate yourself to these larvae through their entire 20 to 30 day process. Not in terms of only just water quality, but making sure that they're fed and the right quality of food, basically the whole way to get through. So that's where it gets very tricky. Now at home, it's really cool because you can do this experiment at home, and then if you get through one round, it's great. You can celebrate it. Maybe you can keep those fish, give them to your buddies, or you know, the good breakthroughs happen in these home labs. I'm not trying to diminish that, but here we don't necessarily have the luxury of that being the one and done, unless we want to do something like a news story or the like, which has its arguments to a degree if it's the right fish or if there's grant money or something that keeps. We have to keep the bottom line after all. But for us, it becomes, okay, now how many of these animals can we get through this larval life cycle? What percentage of them will survive? How much money does it take to get there? And then where do they go from there all the way through to, you know, what are the considerations when they enter a fish holding system and the like, you know, how do they ship? Each one of these things becomes very, very, very precious. And that's why the cost of these animals goes up very exponentially when it comes to paying for staff and paying for all these considerations. And then things that are really ironed out, which is cool, get the luxury of getting some sort of stability.
Yeah.
And then when we get into the frontier stuff, where there's only a single couple individuals that made it through, let's say ever, like the first hybrid tang, so the first sustainably aquaculture angel species X, Y, and Z. That's why we, you know, it's a huge effort getting through that whole process, and for many times could not be, in some cases, cannot be reproduced yet.
Yeah, so I mean, that's tricky. A lot of trial and error too, just figure out that magical combination, you know, whether it's like a temperature thing or, you know, does a certain different feed could be the key. Like there's just so much experimenting to get there too with each different species.
So much. And that's where it's very impressive. You know, I've talked about the challenges, but we're in an age now where we're essentially running wild. We have enough tools now. And thanks to Google Scholar and facilities such as University of Florida, people who publish their findings, we now have enough working baselines that anyone in their basement, in their fish room, has a solid crack at doing a marine species for the first time. And I not only encourage, but I implore them to do so, because that's where I think not only this hobby gets really fun and really, I mean, it's really exciting to breed something for the first time in a great pride, I can only imagine, but this is where our hobby really does transcend to something where it's like, we are here. We are not just here looking at pretty things in tanks, but because of that love, we are now creating
the next level.
They're doing the impossible. No one would breed a Nemo. No one would breed a blue tang without the imperative of our love. You know, in the same way that you can't discredit hunters for the reason we have national parks in the United States and in other countries. The idea that you must have that passion. And that's our third. I mean, we'll go through it. We went through environmental tree hugging sustainability, went through economic sustainability, so that people can actually, you know, we have to be able to keep the facility running, and then cultural sustainability. Does it matter to us? Does it give value to us? And this is the best hobby that highlights that things do matter beyond pure economics.
Yeah, yeah, like, you know, and some people, like I have one buddy, he will only buy captive bred fish, like he refuses. So it takes him ages to get fish, which is good though. Like it's awesome. But, you know, I think over time, too, there's going to be more of that mentality. And it's also, you know, as wild ones are harder to get to, captive ones are definitely going to take over. So it is important for the hobby, especially in the long run, for sustainability and keeping everything alive and thriving.
I do sympathize with the affordability aspect, especially when it comes to these fish becoming essentially diamonds, where there's a select few that are selling to a select few for a very, very, very high price. Yep. But at the same time, you know, we are, I'd argue, in maybe... and it might be a decade long or multi-decade long, like 10, 20-year gap, where there will be a closing of the prices, where it will become less and less and less desirable to collect wild caught individuals versus their captive bred equivalents,
Yep.
with some exceptions. I'm not
Now,
diminishing that as a whole, but the discussion will be more based on what price, what consistency. Do the wild caught ones do better? Do the captive bred ones do better? And I like to see that kind of dialogue per species.
now,
And I think it's exciting to have the tools for that side.
on the breeding side, how important is it to still have wild to just like diversify like the bloodline after a while? Like, so you have like diversified genes versus just, you know, your same pool. Like, how important is that to have the different brood stock?
Oh, I think it's absolutely foundational. Make no mistake, I am not against wild capture. I am pro kind of creating a whole ecosystem the whole way, and acknowledging that the wild ecosystems are not necessarily something we purely extract from, take individuals from, so we can put in different tanks, but to have there kind of be a recirculation of knowledge and passion back from what we observe, what we breed. Oh God, it took us so long to figure out how to breed a Mandarin dragonette, like in someone's lab, hypothetically. They're like, my goodness, that was a journey. And then you hear about them building a hotel complex on Raja Ampat or in Sulawesi. And, you know, to the average person, you hear, oh, that must be nice. I'll go vacationing there. To the Reef person, they don't need a water quality report. They're like, you can't handle that much nitrates and phosphates. You can't just put raw sewage into the system. Where's the intermittent? Where's the waste going to go? Tell me you didn't tear down mangroves to build the buildings right next to the beach so it looks nice. That's exactly what they did. Oh my God, they thought the mangroves were just a swamp. Like, you know what I mean? Like that. Like that's
and there goes the habitat.
It's not even like, oh, I believe that this will be that. It's this kind of like gut realization that's all coming along for the ride because this industry is so ravenous for knowledge and advancement, both technologically and biologically, and now culturally. So I want this always to be because this is our hope, our reservoir. This is all the new fish we always want to find. This is the new fish we want to breed. This is the new genetics we want to introduce. This is the genetics that will make, I don't know, some disease that shows up in the mass farms. We can come back and cure it from the wild source. They shall not be forgotten. They're just going to be treated in a little bit more of a precious way. Maybe as like a bank vault versus a savings account, maybe less than a checking account, you know?
Well, even like on the hobby aspect, you know, if one area shuts down and okay, these can never longer get these fish, but like, oh, okay, we can always have our captive bred side, right? It still kind of, you know, is a gene pool in a weird way.
I mean, and that's another great, I mean, the freshwater aquarium hobby has shown us time and time again that you can have species almost eradicated from wild water bodies. And their captive bred equivalents are not only thriving, but existing in almost every continent minus the unoccupied ones largely. And that's just true for countless cichlids, countless different freshwater species. And it's because we have cichlid nuts, and it's because we have freshwater, you know, killifish enthusiasts. Oh my God, they are a good example. Is this, you know, the pleco people? These are all, we will have the same charismatic branches. People that are saving stocks of bangai, saving stocks of angelfish, that, you know, each one of these animals, they enjoy market value because of our hobby, but trapped inside their genetics could be all kinds of technological innovations, nutraceuticals, medicines. You know, that article that came out a few weeks ago that was very popular, passing around the anti-cancer compounds in corals, you know, of course, you know what I mean? So by having to have these reservoirs here kind of existing in an economically sustainable way, it's also a national service to all of our respective countries, because then you can't use wild animals as consistent laboratory stock when you're trying to figure out that compound from Gonapora. You want, you know, our farm manager, Corey, to breed you perfect copies to his version of those Ghanies, and that's what you can start your experiment with. So now we get all these other industries that attach to ours in a very interesting and potentially very lucrative way. You know, that's exciting. You know, not only can someone brag about finding a new color of coral, potentially could brag about finding a new compound of coral, you know, in a coral in their tank. Oh, mine is helping with Alzheimer's cures, as a matter of fact. Maybe we shouldn't call it strawberry alarm clock now.
Yeah, that's awesome.
They found Ozempic in the guts of a Gila monster.
Really?
That's where it comes from.
Crazy.
penicillin came from a rotting porch on a rotting orange on a counter.
Isn't that crazy?
That's how it happens. Our hobby is just a rainforest on every stand is a rainforest.
Huh, that's crazy. Okay, so going back down to the basic stuff. Okay, like
Yes.
Phyto and copepods.
Yes.
I go in spurts where I dose it to my reef, and then I forget about it for a while. Then I'll go in waves of it. Certain filter feeder corals appreciate. Depends on what fish you have. I'm always a fan of dosing Phyto just to like boost up the pod population. For an average reef tank, like so, if you're breeding fish, I think they're very important to have. But for an average reef tank, would you recommend most people be adding live Phyto to their tanks or copepods on a semi-regular basis? Like, again, it depends what you keep, but I know you culture them all. But
I think there's a twofold answer to both the copepod and the phytoplankton question. We'll start with copepods. With copepods, you're going to get pods in your tank,
whether you like it or not.
Either from a coral frag, from traditionally in the past, people got rock from the wild. So you're going to get copepods in your tank. Now, what specific copepods you may or may not have gotten, specifically also people want to have control. They might be starting the tank as minimally as possible. That might be part of the experiment, if you will. They kind of know all the knowing pieces. Specifically, the Tisbe copepods I cultivate. This is something to be added intentionally with the knowledge that this is an organism, a species that we know will survive. 90% of reef tank copepods handle the flow, handle the salinity, handle the temperature, pretty hard to overgraze on. It's an ability of adding a known known. So do I say that you need to add copepods continuously to have that population? No. That is my answer. If you want to start entirely de novo, or if you want to make sure that for $10, $20, 15, that you want to add one population of a known colonizing unit. If you are trying to use copepods for some of the many discussed applications specifically, such as excess diatom or dinoflagellate removal, maybe you're trying to synergize it like we were trying to do a few weeks ago in one of our Ectasia holding systems. I overfed the clownfish. We had dinos. So I did a synergy. I shut the lights off. I added tons of Tisbes that I knew would actually recruit in the system. I knew would actually grow forage on the surfaces. And I added diatoms, like Catostris muelleri. Mostly just, trying to figure out what interactions potentially there could be, as that is therapeutic for dinoflagellates. So I would say that would be my kind of middle ground caveat. Pods are something, we know the biology of the Tisbe. We know that we'll colonize if we have an excess problem, an excess surplus. We want to speed it up. We don't want to wait for our own Tisbes to catch up. We want to switch up. There's an application. Thirdly, is where we go into, to a lesser extent, the Tigriopus, but definitely more the Apocyclops, and even some of these other cyclopoids that I'm finding, or calanoids even, that are a little bit easier to grow. We'll talk about them next, but these are the ones where I can't look you in the eye and say they're going to colonize your tank. So that's not meant what they're supposed to do.
In my mind, tell me if I'm wrong. Tisbe we just talked about. Tisbe and Apex pods were kind of the two that were the ones I'm like, okay, those are the ones that in my mind would survive in the reef tank, where some of the other ones are more questionable, like tiger pods. Like I think they don't really survive well and they just are snacks pretty quick. But
I would say that a Tigriopus copepod has a higher chance of surviving than an Apo. Now, here's why I say this. So both Tigriopus and the Tisbe copepod are harpacticoid copepods, which is like a $9 word for the crawlers. They attach to substrates. And even though the Tigriopus certainly doesn't love temperatures above 75 degrees, I raise them at temperatures above 75 degrees, 365. They can take it. They're from tide pools that get heated up. Those potentially, the Tisbe certainly, but the Tigriopus is somewhat able, if it can find some secluded area, certainly a big clump of Cato or something, I don't see any reason why it couldn't reproduce successfully in the same conditions that, let's say, a possum shrimp does. If we see those or mysis. Do I see it all the time? No. Do I play with Tigriopus as much as I should? No, I have other stuff. Apocyclops. This is a cyclopoid copepod that occupies the open water column for the most part. The cyclopoids, they are existing in suspension. Now, for the most part, we have solids filtration on these systems. I don't in a lot of mine because I'm trying to feed everything and I can't afford to have a bunch of small snails get caught in a sock every 5 days. But this solids filtration represents a very near and legitimate peril to apocyclops surviving in most conventional reef systems. Now, could apocyclops certainly be applied as actually living in a more niche system where, let's say, you're doing a public aquarium display, you have or you're trying to do a mangrove display or a macro display, you're trying to do something that's a lot slower flow, maybe something that's only aerated, a seagrass tank perhaps, depending on, but stuff that has a lot of overflow and waterfall movement, I think APO is going to have a very difficult time with. That does not diminish their value, especially, and I don't think that they should replace TSBs either. If TSBs are the one answer for, okay, do I want to put it in my tank and have it live? Apocyclops is the answer for, well, what do I feed continuously? Now, we have lots of things like seahorses, mandarin dragonets that are searching the substrate. They're looking for herpactocoids. A TSB that survives in that system can and will become prey, potentially, for that kind of grazer. What the apocyclops interest is zooplankton feeders that are feeding in suspension. What excites me at this point, granted, I do not have the most personal experience with them, and I would welcome comment by anyone who does, is the non-photosynthetic coral keepers. The people who do not have success unless they are feeding in many cases, very specific things. The jellyfish keepers, frankly, also come to mind. I did work with jellyfish for a time at the Mystic Aquarium in Connecticut, and a lot of their issues. What?
I've been there.
Oh, it's a great facility, and Chris Sodergren, when he was there, was an absolute sensei and guiding light in my life. And he trained me how to not only care but breed many of these jellyfish species. Nice. But one species that he had a lot of difficulty with granted his limited resources and time, were the Pacific sea nettles, and they were ones that he only really had success feeding chopped up moon jellyfish to. Now, when he tried to feed the brine shrimp and reed mariculture mix, good stuff, fish eggs and very enriched fatty acids, a variety of reed mariculture products with San Francisco strain brine shrimp. Most of the jellyfish would respond fine. Your upside downs were fine. Your moon jellyfish were fine. Some of the other taxa, memory is a little foggy. But the Pacific sea nettles had huge issues where their oral arms would physically clog and then break off, to the result to the point where it became just more effective in keeping more animals alive for longer to feed them a surplus moon jellyfish production. Oh, so having new options such as apocyclops, where you can grow them in a 5-gallon bucket without air if you want, especially if it is a light and you have some live phyto, go for it. I mean, they are very maintenance free. And that means that for the cost of $15, $20, whatever initial inoculant you buy, you are able to then create a culture for very minimal effort and space and time that you can continuously, at very high densities, they can survive very high densities without shutting off. You can dose that continuously. So apocyclops, in my opinion, has value more towards these more frontier suspension zooplankton feeders. A lot of the stuff we do not have a lot of success with right now, but people want. People want more NPS, and they want more tools to be able to start addressing the problem of how do I keep it alive consistently. The reed mariculture has done some great stuff as far as having preserved answers to that. I think apocyclops is a great answer to let's start developing a set of tools that you can buy, you can grow, kind of sea monkey level stuff, right? You buy sea monkeys, it's implied that you will grow and use that for a time. And then there's a corporation responsible for making sure there's always something you can get for restarting, because no one wants to do this 365 forever for no money.
No, exactly. I actually just ordered some Apex and some Tisbee pods, so I'm gonna try culturing some for fun. I used to do it, and it's been a while, so.
Hey, they're great species too because they're very, very, very accommodating, which is unlike some of the more sensitive calanoid copepods, such as Arcartia, also known as the Arctic pods, Parvocalanus crassurostris, and then Pseudodiaphanous pelagicus. So people are surprising me. People are working with pseudo right now for fun, and that's very exciting for someone like me. But these are different. They're kind of like living spaceships. They're calanoids. They're for, if a cyclopoid is for like a lagoon or a pond or relatively stagnant ecosystem, estuarine maybe. The calanoids are more for big open lakes, big open oceans, big open. They are colonizing these big open water bodies. If they touch something, it's like if it's like a shuttle touches anything. They move, they crash. They are always anticipating open water to a degree, and that makes them a little bit harder to grow because they can't grow to the same density. And they also have like automatic kill-off switches, where if they get too dense and they detect there's too many adults around themselves, they'll stop breeding. So they're a little less leave it and forget it. And they also are much more finicky, whereas a tisbe can eat anything from leftover detritus, the shavings of maybe a dead, unfortunate clownfish or an enemy that might have melted, the bacteria eating and decomposing that anemone or clownfish, the cilia eating that bacteria. The tisbe can eat a great many things, including alive phytoplankton cells. Cyanobacteria can eat a great many things as wonderful forage plasticity. But the calanoids, not so much. They need primo stuff. They're prima donnas. They want live, good quality, preferably vibrio-free algae. They're very, very, very particular in that regard, which is cool because we're now in an age where that's more available. But those kind of enter this new realm of the far more difficult. It's far more of a job to grow them. So why do they have value? Why do I even bring them up? Well, it's because their babies, their nauplii, are very, 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 very small, very, 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 very nutrient dense. They come out like a full lobster dinner. And they're very small.
Perfect for breeding ultra tiny larval.
They're perfect. And because of them, we've had this kind of next realm of breakthroughs. Everything where rotifers were a little too big or they couldn't get the nutrition in there. And then ciliates, it seems, is going to be the next kind of wave where there's actually people working with very tiny ciliates as well that they can kind of gut load with the algae. But those are kind of the general waves of pods and the spectrum of application. And, it used to be, and we've had these talks in the TSA office where, it used to be, okay, it's nice to bring up these other talking points, but now let's only talk about how they might be applied towards an SPS reef. And now I think I can just say I have customers, I have competition, I have customers, I have people that call me up that are just, I've already been doing this, but I just, they're doing that part of it for fun. They might even necessarily be breeding something, but there's a whole set of pod people now. In the same way that there's, I suppose, terrestrial isopod people, and that's the best part of this hobby. It splinters off into all these things.
Yeah, no, definitely. So I guess the other part of it too would be Phyto. Like, is there certain strains of Phyto that you think is worth culturing at home for feeding your systems? Like in my mind, if you're keeping mandarins and pipefish and those type of things, I like to dose it because I feel like it boosts up your pod population. But is that required? Is it recommended, would you say, for the average reef tank?
I would say if you're trying to ensure that your mandarin dragonette has enough forage and you're in some sort of suspicion, don't let that be the only thing you do in a myriad, especially if it's the poor animals getting skinny, obviously. But certainly that would definitely be a legitimate tool, adding phytoplankton purposefully for trying to boost a pod population sustainably, continuously over time, when in particular there's an animal that you're trying to have eat that. Mm-hmm. I think another realm of argument, one that we've been playing more or less in the farm with, that can go back and forth, is whether or not when you're trying to add nutrients, because we are in an age now where the gear is getting to the point where you can strip out systems, and we are dealing with new, weird, counterintuitive algae because of these stripped out systems. Algae is a way, specifically the strains that we are all kind of growing now that have known literature behind them. We know they're not going to run filthishly rampant under these conditions. And we grow them under conditions where, like at best, the Tetraselmis will survive. The sea isochrysal will survive until it's eaten, but they're not going to cause like huge sheets of green water in your tank. So you can purposely be putting some form of nutrients into your system that aren't necessarily the same as dosing just like a straight nitrate or phosphate. That way you're putting something in there in a package, not just necessarily delivering it to whatever might be there already to receive it. So it gives you another tool for being able to raise nutrients in a different way. Yeah. Now, the next way that's very important specifically is, again, falls under the next category of critters that we have not had traditionally a lot of success with. These are your clams, electric scallops. These are your critters that just seem like they just don't last all that long. And when it comes to that, I'd say that the algae that we produce, all of them are very fitting examples of something that can be fed and we know have good fat profiles, good nutritional profiles. They don't have any toxins. Quite a few algae species have toxins. It's something that we can deliberately put in, and more importantly, species specifically that have been used to grow other shellfish, including the giant clams, for instance, which had some convergence in food and ornamental values. There's a lot of knowledge there that T. isocryces, Cattosaurus, Tetrasalamus, all used for that. Rhodomonas used for breeding diadema sea urchins, very famous live feed.
So on that note, just because Stan's in the chat right now, so he's working on breeding sea urchins right now.
Oh, cool. Which species?
Yes. Which one, Stan? And yeah, he's saying like the first time he tried doing T-ISO, it crashed. Then he got an autoclave, and that helped a lot. So I mean, obviously being super sterile definitely helps with Phyto.
Yeah, I mean, do we want to go through that real quick? I mean,
I think it's valuable for sure.
Okay, I'll go through my short recommendations here. This is what I do. This is not some of the stuff we do is a little not secretive, but this is I like to celebrate this. Clean Phyto is good for everybody as far as I'm concerned.
I agree.
So the big thing is to start off with a clean inoculant. So to a degree, be able to trust whoever you're getting the Phyto supply from. It's very helpful at this point to have a microscope so you can take an initial look at a sample when you receive it. Now, that being said, everything you do afterwards, it's very important to kind of set the stage, clear the stage, cover all your bases so that you know whatever went wrong, it's either something you can maybe trace back and play with next time, or you can trace it back to that initial source, and then you can try and develop some sort of troubleshooting protocol. But with that in mind, let's go through what I would do. Let's say if I was receiving a stock from myself. Yeah. So if I received, I don't have it. I wouldn't check to this. Let's say I got this much algae, all clean, sealed up, and I wanted to rear it out in a 5-gallon carboy. So what I would do is I would take the carboy and clean it beyond all imagination.
Boiling water, bleach, icy profile. What do you usually just sterilize?
I want it clean to the eye. You know what I mean? You don't have to go crazy beyond that, but clean to the eye. You can rinse it with tap. You can't have any scuff, any leftover, even dirt or dust. All this stuff on a microscopic scale is a mountain range. A mountain range where bandits can hang out and ruin your time later. Bandits that can cause a revolution and later a crash 20 days in. When cells start to die and they get enough organics to work with. So make sure it's clean to the eye. Get your source of salt water. This is very important and a great thing. All of us reefers, for the most part, are stripping our salt water down with RO and then reconstituting it with salt. That's fantastic. I can't tell you how many oyster hatcheries I've worked with that have driven themselves to madness because they've just convinced themselves that wild salt water is key. Wild salt water exhibits rain, it gets runoff from the sewage, it gets birth control, all kinds of weird stuff in it. It gets rain, which gets more organics, it gets all these different organisms. The pump and the lines they use to intake get clogged, all these organisms. And you can't filter this out. Your filters get clogged at the bacterial level, and you can't bleach it out because there's still environmental DNA and all the bits and pieces. Just because you obliterate, all these things doesn't mean that their components aren't there, and then these things can fuel bacteria, and there's all complicating factors. So the fact that we can start off from RO and then having salt in a vat from that RO is great. Even if the salt isn't necessary, I mean, don't have it be dirty, but we all know that salt isn't spotless when it comes in the bag. Yeah. But for the most part, I mean, it's fine. Whatever bacteria on the salt are about to have a really rough time.
Is it required to do it? There's times where I've just mixed it up and used it. There's been times when I threw it in the microwave to loosely boil it first. Is that required? Is that overkill?
Okay, so here's so I did some training with Gary Wickford's at the NOAA lab, and they did an experiment where we made all these different samples and all this media, and we did different sterilization techniques. Yeah. Microwave, boiling. Boiling is okay. It's not perfect. Alcohol is not perfect because there's lots of bacteria. yeast is a good example that survives alcohol, especially over time. But alcohol is not bad, but not perfect. Microwaving is pretty much not useful. I wouldn't necessarily
waste of time.
I'm willing to have I will have an argument if someone works with it, but like you're killing bigger stuff would be my argument. You're killing affiliate, sure, but again, there's this problem of the environmental DNA that I think is probably an issue for more sensitive species like T-ISO that just can't handle big bacterial loads. They can't really do it that well. They want to get their bacteria nice and minimized and within T-ISO's little world. So bleach is my go-to method for the most part. I like bleach, regular Clorox, whatever outtake lines to the pump and whatever, you want to make sure that's alcohol, whatever it's coming out of, you want to make sure it's not sitting in a pile of, a lot of it is just thinking, where's the water going to touch? What can it interact with? Have I given that at least a spray with alcohol, minimizing contamination load through every conceivable step. So I like to, I put, maybe a cap of bleach per 4 gallons of water. You can kind of play with it. But for the most part, you want to have like a cap of bleach per couple gallons of water.
Yeah.
And then you want to fill that carboy up the whole way. Even if you're trying to grow the algae at this level, do not grow it. Don't just fill it up to this level because this is all still dirty.
Yeah.
All that has you don't even know. You don't even know what's in your tap water. They don't care. No one cares. I don't know about you guys in Canada. In the US, they don't care about us. There's all kinds of stuff in tap water. Don't look under them. But so you need to fill that up the whole way so that bleach, which is relatively diluted in your water, is now touching everything. And you've basically removed every mountain range, every bunker, everything that could prevent the chemical from frying every surface area. At that point, you're going to want to, add your airline. I like simple airlines. I don't like air stones. You want to minimize your surface area. You want to see everything and make sure it's clean. So simple rigid tubing, simple clear, but it's like 3/8. I forget the standard airline tubing. I like that. Big bubbles are key too because they don't provide a lot of shear. Small bubbles like a protein skimmer, it goes through their cells, and once a couple die, you get foaming issues, you get bacteria from that. So put that airline in, maybe even bubble it if you want. Let that bleach circulate, let it hit all the inner areas of the airline. The parts that are sticking out, maybe alcohol that very well. Preferably have a big new airline. Not a good thing for like the used airlines been sitting in a 10-gallon in the shed. Let's do that for pods. And then, so once that's been running for a couple of minutes, you're going to want to have some sodium thiosulfate, which is a $9 word for dechlorinator.
Oh, okay.
I was like, what is that?
Yeah.
You can type into Amazon. We really should just sell it.
So like Prime or like whatever, just some kind of dechlorinator.
Essentially, yeah. The only issue, I don't have an issue with Prime, but I like going with straight chemicals. That way I could be like, what did you do? And I don't have to worry about this is going into your system. I'm sure they're fine, but I want to minimize everything. So I buy the crystals, like $15 for a pound, 5 pounds or so from Amazon.com, sodium thiosulfate pentahydrate. And then with our RO water, which we all have NIFLY in a sterile container, hopefully, which you can do the same bleach and de-bleach thing on in its own right. Mix, I like about 250 grams per liter. It's hard to overdose on the stuffs, but you'll kill everything if you leave bleach in there, Yep. So at 250 grams per liter, you do like a 1-to-4 ratio. The idea is that you don't need to add as much sodium thiosulfate as you do bleach, but you need to add some. You definitely need to add. I like to go with a 1-to-4 or even a 1-to-2 ratio, just to make sure that bleach is getting knocked out. And you're going to want to aerate that. So via the aeration and then the introduction of the sodium thiosulfate, the bleach has been knocked out. Boom. You just cleared your beach. You've nuked everything. And now you've made it so the chemical that's killing everything is gone. Now you can empty your vessel down because otherwise there'd be bleach residue if you did it before.
So use the water that you've basically sterilized as your base.
Yes. Yes, you sterilize the water. Now you can maybe, you might dump some water. You can put it aside, but you have sterilized water you might use aside. But, if you filled up 5 gallons, maybe you dump half a gallon out to get like a nice little. These things are relatively atmospheric to a degree. They interact with their atmosphere. We can't really have the luxury of them interacting willy-nilly because bugs and stuff will fly in. So but we do want to give them, like if it's a conical container, we want to give them like a nice flat area to have their own version of like a localized atmosphere. So we're going to empty it down maybe a half gallon, and then we're going to keep the aeration going. Bubble, 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 bubble. And everything's been nuked, and then everything's been cleansed of the toxin, the bleach. And then we can add our F/2 media, both part A and part B, which we've also added to a sterilized container. You can overdose on this because if the algae cells aren't, if you dose too much fertilizer versus the amount of inoculant of algae that you put in, it's essentially like, dropping the population of some small town in Canada, in the middle of Toronto, and then giving them all the food of Toronto. They'll eat for a day like kings, and then they'll start to rot, and then problems will happen fast, So you want to make it kind of coupled.
Do you do roughly like a mil per gallon, like half a mil of each AB, or do you have a standard that you kind of do?
So if we have, it kind of depends a little bit on the strain, but for the most part, if we have about 5 gallons of culture water, we're tossing in like 20 mils of each.
Okay.
That's a reasonable ballpark.
Yep.
If you're dosing really dense inoculant, like this culture, and that you're not dealing with bacteria, you can go a little bit more. Oh God, I really should. But the one that's more opaque, the pink one, I believe that's actually part B, counterintuitively. All right, whatever. The one that's the nutrients and the vitamins, that one you might want to tend to dose more of.
Okay.
Far more limiting than some of the trace metals. They don't tend to run out of zinc. They'll run out of iron and stuff. So I don't want to say that the other stuff is not important, but you definitely want to maybe supply one over the other. Like a lot of those nitrogen compounds are very important for, let's say, making Rhodomonas stay red. It takes a lot of energy to make that pigment and sustain it the whole way. So you want to, especially with Tetrasalmus too, they're phosphorus pigs. They'll just suck it up. They love it. So like 20 milliliters of each is fine. Okay. And then bubbling, you've added your fertilizer. If you're doing diatoms, you're going to want to add sodium metasilicate. We'll come out with a video kind of describing that process a little bit more in the future. But essentially you fertilize your vessel, and then you inoculate. If I had this much, ideally I would like to inoculate at maybe a 1-to-4 ratio. Maybe you would add 1 gallon of algae for 4 gallons, half a gallon of algae for 4 gallons. A lot of that is very density dependent. In a very dense culture, you're going to want to maybe dose a little bit less of. You don't really want to move huge amounts of these really dense cultures around, rather use small amounts of them strategically to seed other populations. But for the most part, it's that general process of having an alcohol sprayer, making sure your hands are clean, making sure, every part of this interaction zone between you're shedding bacteria, everything around you in the air is not necessarily getting inside that culture before you seal it off with aluminum foil or however you choose to seal it. And for the most part, they are not, at least the ones I work with, are not really able to contaminate each other via the air. They're a little too heavy.
Do you filter your air that you pump in, or you just use a standard pump? Okay.
I do not. I have 2 concerns with that. One, I don't really believe air filtration is economically sustainable or effective. One thing, if I was dealing with anthrax here and we could have an unlimited budget and there was a real imperative, but for the most part, I think it's relatively impossible for me to have true air control. I cannot have air supremacy here. The second I open that vessel to harvest some of it or to get my inoculant, what am I going to have, a hood here? And even then,
fair point. Okay.
You know what I mean? And then they make these air filters, but all they really do is choke up airflow, and they can make your air pumps overheat. And frankly, a 0.2 micron air filter is probably efficacious. I'll be generous for a week.
I'm half asking for that, and he sent me photos earlier of basically building a box with HEPA filters to put his air pump inside of. So I was like, okay, I wonder, how important is this actually for? I've never filtered the air pump other than whatever little stock foamy things on it. So I was curious. Yeah,
I think it'd be more important as maybe a facility wide. Like I consider my mini splits my air filters. It's more as the air entering the general facility in general. But as far as trying to
Fair.
localize it to the actual algae vessel, I think it's kind of impossible. Like your bacteria from the air are going to fuse with that culture. You know, Gary Wickford's Mark Dixon have a great way of describing that. Like we grow pure algae that has no bacteria. You don't want that. It's got the, you know, boy in the bubble effect. It's not valuable. It's not charismatic. It doesn't grow. It needs to be fed all
good hardy stuff.
It doesn't get hardy. It certainly doesn't necessarily play ball with getting bottled and shipped and staying kind of what it is the whole way from production all the way through consumer. But whatever algae you're dealing with, it's going to fuse with the bacteria of your facility. And for the most part, now the exception to this is bugs. Bugs can carry all kinds of anything along with them for the ride. So to mitigate bugs and to keep them, you know, actual sources of water vapor, you know, certainly don't have like a misting unit. Maybe not a great place to have your chameleon enclosure like next to all these
man, I got dart frogs still left to me.
Like foggers going your dart frogs onto your TISO cultures.
I have dart frogs in my Phyto within like 3 or 4 feet.
At Long Island Aquarium, they were growing TISO, and it was feet from a sand tiger shark aquarium. It didn't look contaminated, but you can tell sometimes the ISO will clump a little bit when there's some bacteria. You know, for some algae, that's a way of actually suffocating it out.
Okay, interesting question in the chat. Dusk is asking, is there an argument for pulling outside air so you don't crash pH? I guess, is there pH crash an issue or a concern with Phyto or culture?
It's a fascinating question. I think it's twofold. In the past, especially in commercial hatcheries like the oyster hatcheries I've worked in, there's been an emphasis on purchasing CO2 tanks and dosing them to the cultures like you would for your planted aquarium. I have some issues with that. You'll notice the planted aquariums, they have diffusers. They are not very mobile. We don't really do that when it comes to at least the techniques I use, very heavily aerated. So I'd say that a lot of the carbon dioxide being added could potentially be very expensive for the actual amount of carbon available. Another thing that's very interesting, and I would have to defer towards Gary Wickford and his wonderful staff, is interesting studies in figuring out specifically how the algae take in carbon for their photosynthesis. And it may be, and it certainly depends on the species. It's not necessarily as intuitive of, oh, carbon dioxide enters, algae sucks it up. I'm sure that happens to a degree, but I think there's lots of other ways of which the algae can ascertain that carbon in a way that a CO2 tank, again, because you have to pay good money for that, has to be maintained.
I think he was asking more for boosting pH, but yeah, no, what you're saying about CO2 for growing plants actually is another.
It would drive it down, yes, which is important because one of the things we would do in the past is we would past employment employers that I would do is we would use pH to kind of judge how long the algae was in its growth progression. When we have these continuous reactors, when we would have to do things to keep the culture going perpetually, we didn't have the luxury of like, okay, we're gonna harvest.
Have you done that? I had
this
whole plan way back in the day for like basically a Phyto, but then feeding it tank water through a sterilizer and see if it would like go on forever, basically. But
it's not impossible. It's not, because the same, you have to keep in mind the lab the hatchery I was working at the time was using something called a CCAP system. So they had raw water coming in from a raw ecosystem. It could be a tank. Who cares? Going through solids filtration. And it went through UV and it went through a pasteurizer. They cooked it, and then it was dosed with nutrients A and B, and then that went into a feed line, into bags. And then once the bags hit a certain level that you could change with the flow, you know, that would automatically harvest down the line into a bucket, mix all the species together, dose that into the oysters. In concept, I don't see why. I think that would be, one, a great thing for a public aquarium to do with their infrastructure. With a much hardier species like a green algae would be a great applicant to that. And then beyond that, since, you know, that screams, which is another thing great about this industry, that's how we should be treating the wastewater.
Yeah. I've had all these crazy ideas. I haven't done it yet, but there's all these revisions to like earlier versions of projects that I think would be cool to do one day when I have the time and to actually do it. But
keep it up, because that's the thinking that's going to put the world back together. You know what I mean? I mean, it's just that kind of stuff that we can demo out with passion and small scale. But I don't see any reason why not, because CCAP operated the same way.
Yeah,
you know, you can do
that's cool.
Tank. You need a lot of phosphorus coming into that tank, though. I'm not sure the reef tank will be able to provide necessarily enough for much algae.
Yeah, no, fair enough. No, it's so cool. There's potential in these ideas,
If you're a
right?
shrimp farm or a pig farm,
Mhm. So okay,
or you're shrimping,
so speaking of shrimp, there's a question earlier when we were talking in the chat when we were talking about breeding peppermint shrimp. They're asking like, is there intention to breed, cleaner or the blood red fire shrimp for other ones as well, or like what's the main drive first? Is it based because of aptasia control? Like, what's the main drive for that one versus other shrimps as well?
so the main drive is it's kind of the opening. It's like the gateway species. If you can get lysmata done, you can do peppermint shrimp. Well, I shouldn't say lysmata. That's what the others are too. If you can get peppermint shrimp done and done consistently and well, you can then start to play with the others. Now the big difference is that the lysmata have a much shorter and much more well described and much more people have had success with their larvae.
Okay.
Same cannot be said for amboensis. I think that's what cleaner is, and then Debulus, I think that's fire shrimp. The same can't be said for those. They've been done, but they have much longer larval states.
Okay.
They require a little bit more sensitivity, and then the return that you can expect to get on that compared to a peppermint shrimp as far as consistency is probably a lot less. Now there are people, I know Pro Aquatics is investing a whole new wing of their facility into working with shrimp, and God bless them for it.
Nice.
Because those are great species to get commercially produced. I will say also real quick that especially species like the cleaner shrimp that have very long, kind of annoying larval stages. It's kind of debated how long they need to be. If we could cut this down, how could they possibly be like this in the wild? To work and succeed with that species allows us potentially to open new insights into aquaculture and things like spiny lobsters that have very similar larval states that would have profound impacts. Like truly farmed lobster would have profound impacts worldwide as far as making that luxury item a little bit more accessible to everyone.
Yeah, no, definitely. Yeah, it seems like the food industry side gets a lot of love, but not as much on the aquarium ornamental side. So, but it's nice to see all the different parallels. They kind of boost each other to a certain extent.
It's the best part of like this interaction because it's all the same tech. A lot of people don't necessarily talk. There might be a time, considering we're in a time now where supply chains are shifting at best, being completely disrupted and rebuilt, reconceptualized at worst. These are all converging. Think about everything we've gained in the reef aquarium industry from people that kept plants. In fact, they gave us LED technology for the most part.
Crazy.
I mean, this is not unignorable analogs. Their knowledge of fertilizers, a lot of these products, a lot of these things are converging and very. So I don't ever like the idea that we exist in these bubbles because we simply don't. We don't.
Yep.
And we don't. And the animals don't. And the knowledge is transferable. And we don't necessarily have the luxury of it for answering some of these more nuanced questions.
And they all correlate to each other. Like before I was in reef tanks, I was heavily into planted tanks. And I don't even think dosers were a thing back in the day. And I built my own off like little AliExpress pumps and Arduino and built my own doser. And then I got a reef tank. It's like, oh, this applies here too. Perfect. But yeah, it's funny how all the different little parallels over the years.
Oh, that's great. I mean, even a simple question of should we run a UV or not? I was reading an article about people trying to breed European lobsters, and they're like, oh, this is the system ran with a UV. This is the system without a UV. The one without a UV had long-term stability at some point of bacteria, and the lobsters survived. Mm-hmm. The ones with UV, you kept having the same Vibrio bloom. That's something that's no one probably had a reef tank in mind when they wrote that paper, but it's such a wonderful launching off point to a lot of what we're investigating. How much UV is important when at some point, especially in early system, are you disrupting more than you are maintaining?
Yep. So that's actually a good question. For an average reef tank, would you recommend people run like UV or ozone, or would you recommend they don't?
It depends on your goals. Ozone always kind of freaks me out because of the safety concerns. I'm told that the reactors these days are a lot more safe.
I'm a big fan. I always run it, but I'm always curious on the opinions.
But ozone's pretty hardcore too. I would say, in general, if someone pressured me, that ozone maybe is a much more applicable tool towards large scale operations. I think of like Chris Meckley and his wholesale facility taking in large amounts of wild coral, having to make sure that that biomass can be received no matter how it's received, and gets clean water with only having limited space at the end of the day. Public aquariums, Mystic Aquarium has a giant ozone reactor that they use for their beluga whales that I saw. At that large scale, they get kind of dangerous. At a small scale, it's an incredibly powerful tool, but I'd argue, I'm still in the weeds when it comes to ozone. Yeah. UV, I think, is a perfectly applicable tool, especially for a lot of the systems people are trying to use. I think certainly there's an argument for being strategic when you have your UV as far as how long you're running it into the duration of your system. If your system is first starting off, I wouldn't necessarily be the keenest to immediately start blasting it with UV. Maybe allow it to age a little bit more strategically, have your mind more spent on how am I getting the system set up initially, on a biological level versus bombarding it with immediately different kind of pressures.
Hey, so give me 2 seconds. I just got to quickly help the wife. Give me 1 sec. Sorry.
Late night in Cub, so. Well, if I don't have to start breaking out my stand-up. It's too late for that, or too early. It depends on how you look at
it. Sorry, I got to deal with a couple family emergency stuff at the moment, but
no worries.
I appreciate you coming on, and definitely would love to do this again in the future and dig a bit deeper. But awesome conversations. I love what you do in the lab, so it'd be really cool to see what things turn into.
Yeah, well, thank you for having me. I had a great time.
Okay, awesome. Thanks so much, guys. As always, if you enjoyed it, be sure that like button. If you want to see more Trass, he has an awesome little series you're doing on the Top Shelf channel, so definitely be sure to check that out.
Thank you for having me, Devin.
Okay, awesome. Thanks so much, guys.
All right, have a great night, everyone. Thanks.